Behind the Built Environment, the podcast from BESA, the UK's leading trade body for the building engineering services sector.
Hello, I'm David Frise, Chief Executive of BESA. Welcome to Behind the Built Environment, the podcast where I delve into the major issues facing our industry through in-depth conversations with key industry leaders. Join us as we explore the trends, challenges and innovations shaping the future of the built environment. And today's guest is Fiona Cousins. Fiona Cousins is CIBSE President and holds multiple roles at Arup, including America's Region Chair, Arup Group Board Member. She is also an Arup Fellow, a rare honour reserved for the group's most admired leaders. She previously served as Deputy Chair of Arup's Digital Executive and as Automation Leader, advancing digital transformation and sustainable development. A mechanical engineer by profession, Fiona has worked on many award-winning projects globally, including the US Embassy in London and Fulton Street Station in New York. Under her leadership, Arup's Americas region, with over 2,000 members across 16 offices in the US, Canada and Colombia, strives to realise a sustainable and inclusive built environment by providing expert guidance to clients. Fiona has been recognised as one of the most influential leaders in the US commercial real estate industry and featured in the 2023 Commercial Observer Power 100 list. She is a valued advisor on critical climate legislation and was appointed to the New York City Advisory Board for Local Law 97 in 2019. She is a lead fellow and chaired the US Green Building Council in 2016. So welcome, Fiona.
Thank you. It's good to be here.
Glad you could make it. You're here for 2.5 weeks, you said?
That's right.
So we're very privileged to have you here today. We kick off with 5 quick-fire questions. Try and do yes, no. It's not always as easy as it sounds, but I think you'll be all right with these. So, is the building service industry too focused on energy efficiency and carbon reduction?
Yes.
Should biodiversity loss be a consideration for building engineering projects?
Yes.
Can building services firms meet their performance goals with their current skill sets and workforces?
Probably not.
I'll take that as a no then. Does government have a role to play in delivering culture change in construction?
Yes.
Will all high-risk buildings be safer by the end of this decade?
Maybe.
Yeah, I thought that one. Are construction supply chains currently fit for purpose?
No.
Fiona, first question. How do you end up here today? You're president of CIBSE, you're a fellow of Arup. What made you become an engineer and what was your journey?
So when I was at school, I think careers advice was terrible. The only jobs that any of us were really aware of were the jobs that our parents had and that our friends' parents had. So for me, that was doctor, lawyer, nurse, teacher, engineer, because my father was one. And there wasn't really any advice about what would make you suitable for one career over another career at any given time. So my introduction to engineering were the Women into Science and Engineering activities that did come through when I was sort of in the sixth form at school. And then I went to university to do engineering, and it turned out that actually I was very interested in what it is. I was very interested in creating places and spaces that people lived in, that form the backdrops to people's lives. And it kind of went from there. I got a job with an employer that I've been with for very, very many years. And I have always found that we think hard and work hard to try and make places and spaces, not just systems, although we also make the systems and the engineering work as well. So it just turned out to be sort of an interesting place for me to be in. And I always liked the idea that we were not only solving the detail of the problem that was in front of us, but we were also thinking about the bigger consequences of that. So I would say that that's always been a theme in my career. It's like, how do we make this place beautiful, functional, useful, at the same time as making it properly designed and engineered so that it actually functions? And I think that connection between the sort of the broader impact and the detail of the systems was very clear to me from a very early age. And I've continued to kind of draw the connections between the two pieces over the course of my career.
The influence of parents, as you say, I was 4th generation in the Navy, so it's difficult to dodge, as they say. So, and you spoke about your father was an engineer. Was there one mentor who developed your career, helped you develop your career?
Not really one. I think there were a number of people over time who were kind and generous in the way that they worked with me over time. So there were a lot of people who helped me in my sort of pre-university year when I really didn't know anything, to just expose me to different parts of the industry and to sort of gain enthusiasm around it. After I graduated, I worked as a computer programmer actually in building thermal response. And the person who looked after me there was also extremely kind and encouraging about the things that I should do. Sometime shortly after that, somebody said, yes, of course you could be promoted to be a director at Arup, when I asked them if I could perhaps one day be an associate. And the confidence that those people had in the possibility was just enough, I would say, to kind of keep me going over time. And I've had a series of very good mentors and sponsors over the course of my career.
Great. So there's plenty to discuss there. Is it more challenging, do you think, for building engineering firms to make social inclusion, climate change, and health and well-being a focus for their business when the economic situation is challenging?
I think the answer to that is yes, of course. But I think that the sort of second part of that is how we account for the things that we pay for and how the building industry costs kind of work. And I think that one of the things that, as a mechanical engineer, I've always been challenged with is that the first question out of anybody's mouth when you say, I'd like to buy a better chiller, is, and how much will that cost me and what's the payback? When actually the answer is not necessarily in how much will it cost me and what's the payback. It might be about, and how will that reduce my carbon emissions, and how will that improve the operations of the building, and is a chiller even the right thing to buy, are actually the questions that people should be asking. But the conversation very quickly revolves around costs, and I don't think that that's necessarily always very constructive.
In the report that you wrote, the forward to that CIBSE produced, excellent, Building Performance Reimagined, how should we be reimagining engineering services?
So I think that one of the issues with building services engineering is that we spend a lot of time solving the problem that we defined for ourselves really quite a long time ago. So we solve the problem of how do we provide a comfortable environment that is cost effective, maybe energy efficient, maybe carbon efficient, and that the owner can afford. And it's a fairly straightforward question to answer. But actually over my career, and I think probably over yours, what good looks like has actually changed quite a lot. If we look back 5 or 6 or 7 years, none of our clients were asking for decarbonisation, and now all our clients are asking for decarbonisation. If we look back 25 years, nobody was even really asking for energy efficiency, and now people have asked for energy efficiency, but now they're more interested in carbon. As the electrical grid begins to decarbonise, energy efficiency is perhaps becoming less important because people have been focused on carbon. Embodied carbon, embodied energy are beginning to become more important. So we've been working in a changing context for a really long time. And I think that means we have to think really hard about what the question we're asking ourselves is as engineers. Engineers are brilliant at solving the problem once the problem is defined. But I think that what we actually need is a different problem solution, a different problem definition, something that is a little bit broader, that takes account of more social or more biodiversity kind of criteria, and that more directly addresses some of the carbon and climate change problems that we're aiming at.
I think from our members' perspective as contractors who come in, with a consultant-led design by and large, every project starts off with fantastic ambition, and a lot of time and energy is spent on designing a building the client then works out they can't afford, or a quantity surveyor says that. And then suddenly you get into value engineering. How do you stop that process when you still have this purpose, these ambitions?
So I think this is sort of back to that question of costs driving everything. The best projects that I've worked on have been projects where right at the beginning, the design goals have been set so that they're not just something that I can afford, but that it's something that I can afford that is also carbon neutral, or that also delivers a certain programmatic requirement, or that was also restorative for the natural environment. And if you can bake those things in at the beginning of the project, at the very, very beginning of design, and say, actually, this project will be successful if, and it's more than just on time and on budget, then those things begin to permeate all the way through. And then it becomes much more difficult to kind of unravel some of the individual pieces. The value engineering works by attacking the line items that look like they're costing more than they otherwise might. But if everything is actually more fully integrated, that the reason you've got a heat pump is because you want to have a fully electric building because actually you want to be zero net carbon over a period of time, you've got a very different kind of set of criteria. You're not going to suddenly say, well, the heat pump's more expensive than the chiller would have been, or whatever it is. This is a little bit of an old-fashioned example, given that nobody's putting boilers in anymore. But this idea that you can't strike out the line item if you've kind of on the basis of cost, if actually it's fundamental to other things that you have deemed as success points for the building.
In your foreword to the report, you point out that 90% of us spend 90% of our time in a building. So for the buildings and the built environment is really important. I think we were talking about whole life cost maybe, or short-term cost versus whole life cost. But should we be really looking at whole life value that building brings to society?
Yeah, I think that whole life value is probably the right way to look at it. And it's not just about value in terms of cost. As you say, it might be value in terms of what's the contribution to society in a broader way. Is it about carbon emissions? Is it about biodiversity? Is it about places that the community can gather at? Is it about buildings that face outwards and improve security on the street rather than face inwards and don't have any eyes on the street? Is it about buildings that have different purposes at different times of day? Because that's one of the ways of getting the most value out of our real estate. It's those kinds of questions, I think, are the questions that we need to begin to ask ourselves.
In the UK in particular, and I'll ask you about the US later, but the Grenfell Report was published a few weeks ago, which is a damning indictment of the culture of the industry. How do you see that being integrated into this picture of better built environment, but a safer one? Is there a danger we make buildings safe and in the short term from fire, but actually in health terms, probably less safe by sealing them up, say, and not properly ventilating?
So I think that some of the things that we discovered in the Grenfell Report were about not taking the broader view. So to your earlier question about cost, the costs were driven down, and they were driven down in the most effective way that they could be, and as quickly and as hard as they could be. The people involved have been shown to have taken their eye off the kind of overall safety ball. They weren't perhaps as aware of the outside environment as they should have been. And I think that this piece about what is the bigger problem that we're trying to solve, where is the value, right? The value is in safe buildings. It's not in unsafe buildings. The value is in doing things right and doing things right the first time. And some of those kind of broader criteria, whether it's safety or climate change or society, are all about not solving just the problem that's in front of you. How do I design the cheapest facade system that I can put on the outside of a building and install it as quickly as possible? But how do I make a safe building that contributes to climate change mitigation, that is safe in times of climate change adaptation, that perhaps supports biodiversity? It's kind of these bigger picture things need to be integrated into the design problem that our engineers and contractors are trying to solve. Because if they're not, you end up with these other kinds of disasters. And it's not about a particular thing that you do. It's about a general awareness that permeates everything that you do. It's like, is this the right decision? Am I solving the right problem? And I think we are not always very good at kind of lifting our eyes to the horizon and thinking about it. We think about, what's the problem I've been asked to solve? How do I do this thing at the lowest possible cost? If that's the problem you're trying to solve, you aren't going to get the very, very best answer.
We're very project-based, and we get ourselves, dig ourselves holes, get ourselves out of it, and then call that innovation by and large. You're based in the US now. What differences do you see there from the UK in the way services are delivered?
So the US is a very big place, and I think that there are some things that we see around regulation. So the regulation is very, very variable depending on which part of the country you're in, and actually even sometimes which city you're in. So some places like New York City have things like Local Law 97, which is a carbon emissions regulation that applies to all buildings retroactively, whereas most of the country has building codes that only apply when you're building new or perhaps when you're renovating buildings equipment. So that's there's huge variability within the United States itself. And I think that in the UK, it's a little bit more uniform, but I think that there are still moves that could be started, right? So the building regulations largely apply to new buildings. There are some regulations that apply to buildings after they have already been built. Some of the European introduced legislation about reporting building energy use, putting energy certificates into buildings, those kinds of things begin to sort of approach what happens after the building is complete, but not necessarily quite to the extent that New York City has gone to, which is we'll fine you if you emit too much carbon, and we don't care that you're a brand new building, a really old building, that you've had a boiler for this long, that it's a very different kind of view.
You were talking about in New York they fine you. Is that if you don't meet the targets? Is that something we should do? There's such a lack of enforcement in the UK that it's pretty much laissez-faire. As long as it looks like the thing you put in for planning, you're golden, so to speak. Whereas we all know there are buildings that are nowhere near their energy performance targets and therefore their carbon targets.
I'm not sure whether you should or should not fine people. As New York City always says, we don't really want your money. We want you to have a well-performing building. What we actually want to do is carbon emissions reductions. And so there's actually quite a lot of support built into the New York City regulations and rules about how you transition to become the kind of building that does emit at the level that we want you to emit. It is somewhat revolutionary to begin to look at buildings that already exist and to put fines and a price on non-compliance. But I think, with every policy question, it's always, what is it that you are actually trying to regulate? What is it you're trying to achieve? And what is the most direct way there? And then what is the most politically possible way there? And how do you get those things to line up?
Can we move on to climate change mitigation? So we're at the sharp end of, I think, something that when I was a child would never have dreamed of, which is overheating in buildings. They were always massively underheated, is my recollection anyway. How are we going to deal with overheating, massive amounts of rainfall but also water scarcity and air pollution in the future? What's our role in this?
So this is a slightly complicated question for me because I live in the US where actually overheating has been a problem for years. And most buildings, certainly in the south of the country, are air conditioned and have been, and that includes residential. So the question becomes less about, if you want a building to be cooler in the summer, then you air condition it. There are ways of doing that. And as we move towards putting heat pumps in for heating, actually you put in a reversible heat pump and suddenly you've got cooling as well. So there are ways of dealing with residential overheating, and many of the bigger kind of commercial buildings are already air conditioned or comfort cooled because they have to be. There is definitely a change in the way in which we use buildings and a change in the way that buildings are operated. One of the things that you can also learn if you live in a place that is regularly warm is you can learn to keep your buildings cooler. So there are many things that you can do sort of passively to make sure that your building doesn't overheat. So I live in a non-air conditioned apartment in New York City, and we always close the blinds before we leave in the morning. We always close the windows before we leave in the morning if we know that the temperature is going to be in the high 30s over the course of the day, because actually when we come back in the evening, it's then still more or less as it was when we left it in the morning, and you can perhaps cool it off overnight. So I think there are some things that we can do in residential buildings that allow us to deal with overheating by operating the buildings better without necessarily providing air conditioning. But it's an enormous sort of public awareness education campaign in order to be able to make that happen. More difficult in commercial buildings because part of the problem is the internal heat gains, but there are still things that you can do by way of shading, controlling solar gain, all of the things that you would worry about if you wanted to overheat a building. So I'm aware I haven't really answered your question because your question was sort of everywhere. But if you are looking for climate change mitigation, the point is to do all of that in as low a carbon way as possible. So what is the right thing to do? Is it to put in air conditioning? Perhaps. Is it to operate that air conditioning with your lovely new, clean, shiny, carbon-free grid? Maybe that's the right approach. Maybe a better approach is insulation, shading devices, building control, and so on and so forth. It's like that. I haven't done the math, but the math needs to be done.
Yeah, I think that's the most polite way someone said that was a rubbish question, but thank you. But it brings up another point about operation of the building. We have a heavy focus on design and installation of the initial system, where we save £25 here and £50 here, and the long-term cost is much, much greater than that. But should we focus more on facilities management and how we actually operate the buildings to get the maximum benefit of the systems that we design and install?
I think the answer to that is clearly yes. And we have actually tools to do that we didn't used to have. So when I was first working, perhaps when you were first working, it was the back end of pneumatic controls, and you could just about manage to kind of have a few on-off switches in various places around the building. And things got better through DDC, and then they got better again. And now everybody's got web-based controls, and sensors, and have become much less expensive because many of them can be wireless and self-powered, and so you need to run less wire. The whole thing has become much, much less expensive to control and manage. So there are definitely better tools now than there used to be able to kind of keep control over what your building does and how it does it. There is a difficult part here, right? When you are designing a building, you build the very best energy model that you can to understand how the thing is going to work. And you build into it all sorts of things about how you think the building will respond thermally, how the piece of equipment will be operated, what the partial load characteristics of that thing are, and how much, whatever it is. It's an enormously complicated model to build. And so we know that the energy models that we provide during design are approximate at best. And then we know that the contractor will install something slightly different. They'll buy a different piece of equipment, or the manufacturer will change the specification or something else. So that whatever the energy model was, it won't reflect what is actually built. So one of the things that I think we have seen a lot of in the last few years is, instead of trying to build up an energy model from the bottom, system by system, actually with the cheapness of the sensors and other things, what you're able to do is you're able to say, under these conditions, with this many people inside it, and using these kinds of characteristics, this is how my building is operating, and this is how much energy it's using. And then people are beginning to use AI and other kind of methods to say, okay, so how do I make this more efficient? And if you let the AI do it, then actually you can get to a better place, perhaps from an operational standpoint. So I think that it was always tricky, right? We know that 20% of people in buildings are always uncomfortable. That's what Fanger told us. And we still know that to be true. So there's always somebody will always be uncomfortable. So somebody can always go and adjust something to make the person who's sitting in seat 11B a little bit more comfortable, because they tend to run hot or they tend to run cold. But actually what that does is it tends to put the systems more and more and more out of kilter over time, and operate less and less as they were designed to. I think with the AI tools, you can begin to get to a point where the buildings can be more readily optimized, but you've only got the data that you have from that building in order to build that AI. So if it's a poorly operated building, you may still never get to kind of the sweet spot. So there's a thing that I think bears thinking about around what's the role of a bottom-up model compared to a kind of AI data gathering model, and is there a point at which those two meet so that you get really good building operations? And then, having decided that that's what really good building operations looks like, how do you then make sure that the people who are actually operating the building have the tools that they need to make sure that it stays in tune over time?
And skills. How do you see our skills developing? What areas should we be looking at to develop our skills so we can deliver these buildings with AI and other new technologies that are coming in?
So I think there's certainly some idea that we need to be more sort of facile with data and digital understanding, and have a little bit more sort of conceptual understanding of how we might be able to get these buildings to work. I think that there is a piece that we can also build in. What is the thermal response of buildings? This question about how do you stop buildings overheat in the first place, that's a thermal response question, and it depends very much on the building. Is it high mass? Is it low mass? Has it got low mass finishes on high mass? What are we looking at? How does the building actually respond? So there are skills around digital. There are skills around understanding how a building might react and to thermal stimuli of various kinds. There are skills around, well, what's the system here and how does this actually work? And then there are skills about what's the equipment and how do I actually make the equipment work? So the role of a building engineer, an operating building engineer, actually has to cover quite a lot of ground. And I think there's been a tendency to emphasize the skills that are to do with keeping the piece of the machinery running, as opposed to keeping the whole of the building running and optimized. And it's a much broader skill set than I think is generally hired for.
I think contracts generally say keep the thing running rather than optimizing performance. But
right. Which brings you back to this question about keeping the thing running is the thing that is valued. That's the performance that is valued. But actually, it could be that what is really valued by society as a whole, and perhaps this is where the kind of carbon taxation comes in, keep the thing running and avoid my carbon fines, would be a better kind of criterion to be solving for. In other words, you need to change the problem statement.
One of the things we discussed before we came in over a coffee was diversity in the industry and the lack of diversity. It's a two-part question. Firstly, how do we deal with that? How do we get less people looking like me in the industry? And is there a difference between here and the US and how they're dealing with that?
Yeah, the problem with the questions about the US and the UK is that I've worked almost my entire adult life within the US. So I am much, much more familiar with how things work there and the way that the industry is and the way that people interact than I am here. Obviously, I work for an international company, so I hear both ends of the story, but my experience is pretty much all American. I think things have changed enormously over my career. When I first, my first experience of a building site was a Women into Science and Engineering trip to go and see the Elizabeth Conference Centre opposite Westminster Abbey when it was under construction. And I remember walking in and thinking, oh my goodness, this is what building sites smell like. It's that smell of fresh concrete that people who go to building sites are very, very familiar with. And I loved that visit, and I sort of became an engineer partly as a result of that and partly because I had very, very good experiences in my pre-university trainee year working at Arup. It was just a really, really exciting experience to be amongst adults who were trying to do something, trying to build beautiful things that functioned. It was a really inspirational year from my point of view. But even though I found that environment extremely welcoming, when I left university and joined, I was one of 10% of women in my graduating class. I was probably one of 20% of graduates as a woman going into the company. And by the time I was 26, I was the oldest woman in the room. And I have been the oldest woman in the room pretty much consistently ever since, because I think things have got better. And I think that for the women who were a little older than me, it was a very, very unwelcoming environment. Society was different. Things became problematic when they wanted to do some time at home and some time at work. And sort of the idea that you could become a very, very busy person in your 30s was less well understood and less well kind of catered for by the working environment. And it is definitely better now. The environment is also more welcoming. When I, first went to work, there were page 3 girls all over the office, and now there are not. So there's a sort of a piece about kind of respect that came in very quickly. I mean, 30-something years ago at this point. The industry has become more welcoming, but there is still a question about you tend to have to prove your competence a little bit more often and a little bit more clearly if you come in from a minority standpoint. Certainly as a woman in engineering, it's like, what do you know? As you get older, you have more wrinkles, more grey hair. There's fewer of those questions because you tend to not just be the oldest woman in the room, you become the oldest person in the room, and people are a little bit more respectful of that length of experience. So it has become better for me personally as I've got older, but I think it has also become better for the younger women. I think that the issues that arise for the ethnic and racial minorities are kind of similar. There's a sort of tendency to judge on stereotype, and then a need to kind of prove and prove again. A sense that, you might be the diversity hire and therefore there's not room for another one, when actually that may or may not be the case. Right? It's always like, well, you can get a woman promoted, but could you get 2? Can you get a black person promoted, or can you get 2? It's a sort of second question. There's a little bit where I think we see it and then we wonder if actually it's possible for that next person to come in, or whether people feel that they've met their diversity targets. So this kind of proving again, I think becomes perhaps the biggest barrier for minorities of all sorts.
Within the industry, in your role as president of CIBSE, how can CIBSE and BESA, as representing the contractors, what can they do together to improve the industry?
So I think there are lots of things that we can do as engineers to improve the industry. When we were talking over coffee, we were talking about how much of what we do, the very, very best that we can expect, is that it disappears into the background and nobody notices it. And I think that the problem with, that's clearly something to aim for. We definitely don't want people to be thinking about their heating systems all the time. We want them to be thinking about living their best lives while they're in the buildings that we have constructed and designed. But we do need people to understand a little bit more about what it is that enables them to live their best lives while they're sitting in buildings. So a little bit more value needs to be attached to good buildings, things that keep you comfortable, things that provide the environment for you to do the thing that you want to do, things that mitigate climate change, things that allow you to be healthy and well. And all of those things, I think, are in the remit of the building services engineers and the building services contractors. Is the building properly ventilated? Is that ventilation safe? Is it comfortable? All of those things are things that we should value, but we've spent an awful lot of our time in the past trying to make them disappear. So there's a sort of question about how does the industry make sure that the things that we provide are valued without necessarily making it so that you notice your heating system every time you walk into the building. What are the things that we need to do in order to be able to sort of change how people think about and view the infrastructure that they rely on all the time? So I think that the answers are things to do with advocacy, they're to do with scientific literacy, they're to do with demonstrating and showing what it is that we do over time and in different environments.
Final question, and that is, are you optimistic about the future or pessimistic?
I think that it's necessary to be optimistic. I think that there is an enormous amount of work that we can do if we have hope. So people will say things like hope is not a strategy, but actually I think hope is a strategy, because hope is only really hopeful if you back it up with action and with doing things. So I think you have to be optimistic about the possibility of change. You have to have hope that you can change things, that you have some agency, and then you have to figure out what it is that makes that hope real.
What a great answer. So if I can just summarize what we've discussed today, the engineering services are very important to everybody's lives. We all live in the built environment, spend 90% of our time there. So actually what building engineering services engineers and contractors do makes a big difference to people's lives. Most of the time they're really unaware of what has happened. They only value it when it doesn't work, say. We need to sharpen up our skill sets to take into account technological developments such as AI and new technical developments in equipment. We need to make buildings safe, but not at the expense of buildings that work. So we don't want to create long-term health issues by sealing buildings but not properly ventilating them, for example. And we need to start to look at how we make the industry more diverse, and not simply to hit targets, but actually you get better results. People think differently from different cultures and they add to the overall picture. I hope that sort of summarizes what we've discussed today.
Yeah, I think that sums it up.
Great. Fiona Cousins, thank you very much.
Thank you.
And now on to the podcast news. BESA member meetings are being held around the UK in November, and the topic of discussion is the Building Safety Act. Visit thebesa.com/events to register and ensure your colleagues come along too. World Ventilate Day is back. Taking place on the 8th of November, BESA is proud to be an industry partner to help raise awareness of ventilation and recognise the ventilation and clean indoor air community. Make sure you shout about everything that is great about ventilation and share on your socials using the hashtag World Ventilate Day and We Care About Healthy Air. Find out more at worldventilateday.com.
Thanks for listening to Behind the Built Environment podcast from BESA. If you like what you heard today, then please follow and rate us on your favourite podcast app. Come and join us over on LinkedIn, BESA Group, and carry on the conversation. And if you want to find out more about joining the BESA community, then please visit thebesa.com to start your journey with us today.